Good afternoon, Wolfpack, and welcome to lesson 4.10 on quadrilaterals. Our essential question is what quadrilaterals are connected to a parallelogram. So let's recap. With a parallelogram, both pairs of opposite sides are parallel. So this side is parallel to this side, and this side is parallel to that side. The consecutive angles are supplementary, which means that the red angle, I'm trying to make that red. Let's see, there we go. The red angle plus the green angle equal 180 degrees. Okay, so red angle plus the green angle equal 180 degrees. Both pairs of opposite sides are congruent. So this side is congruent to this side, and this side is congruent to that side. I know it's getting a little bit messy right there. Both pairs of opposite angles are congruent. So the red angles are congruent to each other, and the green angles are congruent to each other. The opposite angles are congruent. Both diagonals bisect each other. And so I'm going to actually erase this, draw diagonals that bisect each other. So we now have this piece is cut in half, and this piece is cut in half. It does not mean the diagonals are equal to each other. It just means the diagonals cut each other in half. And at least one pair of opposite sides are congruent and parallel. So this side may be congruent and parallel to this side, or opposite. The left and right sides may be congruent and parallel to each other. Those are all properties of parallelograms. Now we're going to talk specifically about types of parallelograms. All of those properties of parallelograms exist for these, plus there's extra special characteristics. So a rectangle is a parallelogram that also has all angles congruent to each other because they're all 90 degrees, and the diagonals are congruent to each other. So AC is congruent to DB. A rhombus has all sides congruent to each other. Their diagonals are perpendicular, which means their diagonals form 90-degree angles. So AC and DB, where they intersect, 90-degree angles are formed. And the diagonals bisect the angles. So that means that diagonal AC is bisecting angle A. So this little angle right here is equal to this little angle right there. The angle A is cut in half into two equal parts. Well, a square is special because a square gets both of the rectangle properties, all angles congruent. It gets all two diagonals are congruent. Plus, it gets all three rhombus characteristics. All sides are congruent. The diagonals are perpendicular. And the diagonals bisect the angles. So it gets all the rectangle properties and the square properties. You can see that the sides are marked congruent, the angles are all right angles, the diagonals are congruent to each other, plus they form 90-degree angles where they bisect, and then angle A was split into two equal parts. Okay, so it gets all five properties, the two rectangle properties and the three rhombus properties. So I want you to take this information, I want you to pause the video, and I want you to put an X in each of the boxes that's a property of the parallelogram. Then push play and check your work. So go ahead and do that now. So as you can see, a rectangle, all angles are congruent and its diagonals are congruent. A rhombus has all sides congruent, diagonals are perpendicular, and diagonals bisect angles. And then a square has all five properties. So let's look at example 2A. We're going to classify the parallelogram. We already know that it's a parallelogram. So the diagonals bisecting each other is a normal property of a parallelogram. But I see that the diagonals form a 90-degree angle with each other. So that means it could be a rhombus or a square. Well, I don't know. In order for it to be a square, all the angles would have to be equal to each other, or 90 degrees, and I don't know if they are. So all I know is that this is a rhombus. I cannot say it's a square because I don't know anything about the angles. Letter B. I can see that all the sides are equal. So since it's a parallelogram, this side is equal to this side, and this side is equal to this side. Well, they're all marked with one tick mark, so all the sides are equal. But also, all the angles are equal to each other, because in a parallelogram, opposite angles are equal, and same side interior angles are supplementary, so they're all 90 degrees. So this would be a square. It's either a square or a rhombus, since all the sides are equal, and since all the angles are 90 degrees, it makes it a square. Example 2C. I don't know anything about the sides. I do know that the opposite angles are equal to each other, and this angle has to be 90 as well, because this angle and this angle add up to 180, so that means this angle is 90 degrees. So I know it has 4 right angles, 4 equal angles. That means it could be a square or a rectangle. However, the sides are not marked congruent. There's not enough more information to tell us. So this would be a rectangle only. Let's do 3 more to try it. Classify the parallelogram. All I know is that the diagonals are bisecting each other, which is a property of the parallelogram. However, since each piece of the diagonal is the same length, that means the diagonals are congruent to each other. Well, diagonals congruent to each other is either a rectangle or square. Looking at that shape, is there any other information that tells us it's a square? Do we know if the sides are congruent? No. We don't know if the angles were being bisected. So all we can prove is that it's a rectangle. Letter B. Because it's a parallelogram, the opposite sides are congruent. However, because they marked this side with 1 mark and this side with 1 mark, that means all the sides are congruent. All sides congruent is a rhombus or a square. But in order for it to be a square, we also would have to know something else. Are all the angles congruent? We don't know. Are the diagonals congruent? We don't know. Are the diagonals perpendicular, or do they bisect the angles? We don't know. So we can only say this is a rhombus. It's enough information to say it's a rhombus, but we can't take it that step further and say it's a square. Last one. These, the diagonals bisect each other, but they're also equal to each other since they're each marked with 1 mark, so the diagonals are congruent, so we definitely know it's a rectangle, but in order for it to be a square. But also I noticed that the diagonals are also perpendicular, which is a property of squares as well. So yes, it's a rectangle, but even further than that, it's a square, because the properties show that the property of the diagonals being perpendicular has been met here. So a rectangle is a parallelogram, and a rhombus is a parallelogram. So we have parallelogram, then we have rectangle, and we have rhombus, and then a square is almost like the child of the rectangle and the rhombus. A square is a rectangle, a square is a rhombus. So if it's a square, it's a rectangle. If it's a square, it's a rhombus. But it's possible to be a rectangle and not be a square. It's possible to be a rhombus and not be a square. So these properties of quadrilaterals and parallelograms are properties that you definitely are going to have to become familiar with. But we will do the back page in class together. If you have any questions, please make sure that you're writing the questions in the margins. And I hope that you guys have a great day. See you later, Wolfpack.